Welcome everybody. Welcome everybody to the Smart and Snark podcast, where real software engineers and real software managers discuss real software. On this podcast, I have with us today the most beautiful disaster, Mr. Matt Jaffee. Jaffee is a world-renowned computer scientist and astrophysicist. His role on this podcast is to try to educate us all on the value of technology and ultimately why we should submit to his authority. Myself, I am myopic middle manager Jason Allison, whose role is to look good in front of upper management, claim to understand technology, just to try to look good. This is season 0, episode 1-2. It's called Bugs Got You Down. Jaffee, I gotta be honest today. I think this is opportunity. I'm not feeling all that hot. I'm feeling a little bit under the weather. Do you get sick at all? Do you have any sicknesses other than that look disease, the how you look disease? Other than that, you ever get sick?
No, actually. But do you think you might have a bug?
I am feeling. I've been a little bit under the weather. It's the timing. I usually get sick like twice a year, and then the kids go back to school, and when the kids leave school, I don't know why weather changes or something. I don't know if you have any advice. I'm a very big cough drop fan. I always get sore throats. I got some Ricola. They got the best commercials. And then I got some Halls. I go from different sets of Halls. The is that the eucalyptus or the menthols or whatever that is, and then the cherry bombs here. What kind of advice you got? Any like home remedies? Anything on the flip side that you can kind of help me with?
Well, Jason, you're actually in luck because this entire podcast episode, I am going to tell our audience about debugging, and it sounds like that's exactly what you need.
I really do. So what I'm hearing you say is the value you're going to deliver is making me feel better after this podcast. Now I'm going to bet against that, just because
As a manager, no, you're going to feel terrible after this podcast. But
okay,
if you're a software engineer or looking to become a software engineer, you might find some helpful tidbits here. And actually, honestly, if you are a manager and you want to be able to sort of coach the people you manage, maybe slightly foreign concept, but you also might pick up something here.
All right. Thank you for that. I'm feeling a little humbled. I want to apologize now. If I happen to nod off during the podcast, it's not you. I mean, it is you, but it's really not you. So let me hand this over to you, and I will do my best to not nod off here.
Yeah, stay engaged. Yeah, you can feel free to mute as well. That's you're making the editing real easy. Okay, so debugging. So what we're going to do today is we're going to talk about what is debugging. Just do a quick definition, make sure everybody's on the same page. Types of problems that you may need to debug, some strategies that you can employ to tackle these debugging tasks, and some common pitfalls. Yes.
How does one know they need to debug? Will we be going into that also?
Yeah, I think it'll become pretty clear, but hopefully we'll cover that. But keep it in the back of your mind if you feel like we haven't. Okay, so what is debugging? Debugging is the process of finding and fixing faults in software. Okay, not going to ask the obvious question. That's fine. I'll do the whole thing myself.
No, I mean, why are people, why are there moths in software, hamsters? I don't even know what kind of bugs there are. There's a lot of 19s or 17 viruses, matrices.
So the obvious question was, what is a fault? And a fault, in my opinion, this is my definition. I looked up some and I thought they were all stupid. A fault can be any undesired behavior in software. So that casts a pretty wide umbrella. Hang on a second. Any undesired behavior. So that could be something very simple, like the function add 2 is adding 3, and that's obviously wrong. Or it could be something much more complicated. Be like, hey, this is slower than I want it to be, or like a performance problem, or this thing is like behaving weirdly some of the time, but not other times. All kinds of different things. So I would say that debugging strategies can apply both to sort of traditional classical bugs as well as performance problems. And so that's why I define it that way. Question?
I was just feeling a little snarky. I gotta not be snarky, and I need to learn on this episode, and maybe what I can take away from this is you talked about undesirable behavior, and I guess, does that make you a bug, and I need to figure out how to get rid of you? Is that's because that's what I'm going to try to take out of this, but I need to be a better listener right now.
I agree. Undesirable behavior can crop up all over the place. So let's talk about types of problems that you may need to debug, because there's a surprisingly wide variety. Um, it could be that in the course, and I think every developer is familiar with this. Like you're writing some new feature or something, and you go to test it out. Either because you wrote a test or because you're just trying to see if it works, and it doesn't. It does something wrong. Now, what it does wrong can be any number of things, uh, but the distinction I want to draw is something that you found in the course of your work, or something that someone else has reported to you, and now it's your job to try to fix, because those are two very different vectors to come into debugging.
Is that like the
Um,
thought of finding something during development versus finding something that maybe is in production? Is that the differentiation we're talking about?
yeah, I think that's pretty fair to say. Like if you find something during development, the big differentiator is reproducing the bug. If somebody else reports something to you, your first job is almost always to reproduce the problem. Because if you can't reproduce it, that makes it very difficult to fix. And sometimes you can't, and we'll talk about some strategies you can employ if that's the case. But usually, most of the time, the first thing you want to do is reproduce the problem. Now, I actually just told you a lie, because the first thing you want to do is not reproduce the problem. The first thing you want to do is understand the problem. Um, and I know I laid this all out in the agenda that we were going to do strategies and then pitfalls, but they tend to intertwine, because the first pitfall is failing to properly understand the problem. Um, a lot of times, what can happen is somebody reports a bug, and there's some obvious thing that pops into your head, and you go and you jump in and you try to fix it, and you discover hours later that you didn't actually understand what the problem was in the first place. um, and it sounds silly, but I see it happen all the time, right? And customers are notoriously bad. And by customers, I mean customers in the broadest possible sense. People are notoriously bad about reporting bugs and bad behavior. They'll be like, even like seasoned engineers will be like, yeah, it didn't work. Okay.
Yeah, is it fair to say that it's the differentiation is, between the way you want it to work and the way it's intended to work? So is that the distinction you're making? Like, just because it's operating a certain way and you don't like it doesn't mean it's a bug. Is that what we're talking about?
Oh no, even given that it's definitely a bug, if a user says it didn't work, you have to figure out how it didn't work, right? Did it crash and give you a stack trace? Did it hang? Did it give you incorrect results? Like, and then once you've established what actually happened, like what is the context around it, right? Like what environment are they running it in? What system are they running it on? How long have they been running it? What type of workload are they putting it through? There's a lot of things that you need to understand to 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 really like have a good shot at fixing this bug in an efficient way. Um, and so I think the first step is almost always information gathering, right? Like you need to build up a context of what the issue is and how it's happening. Now, sometimes you're working in a system that you're very familiar with, and this is really easy to do. And sometimes as soon as somebody reports a bug, you're like, yep, I know exactly what this is. I was just in that code. I know, I'm like 90% sure I know what's happening. And so then go like check that out. And if it's not obviously that, very quickly, then go back to step one and start gathering information because you made a false assumption. But that's okay. If you're experienced in a system, it's actually good to just try to jump right into it and fix it quickly. Just know when to back out and go back to step one if that doesn't work. The 10% of the time that doesn't work. If you are not experienced in a system and you need to debug it, the first thing you want to do is build up a mental model of that system. You have to, even just like a very coarse model, like what are the components? How do queries or data or whatever it is flow through this system so that you can start to know like where to even look. If you don't have like a good or at least a decent mental model of the system, it's going to be very, very difficult to make any progress.
How does somebody get the information needed to make the mental model? I mean, there's got to be ways to kind of seed information into that thought process and kind of what to do with that and where to go with that. I got to believe that the user can help in that situation.
The user,
Thinking about the person who had the issue, there's probably a base set of information that can be provided to help build that mental model, especially for people who are not super familiar with the system.
yeah, it's tough because we're talking in generalities. So if you're the developer of a library and somebody's using your library, there's probably a lot of moving parts that you're not aware of. But if you're the developer of a SaaS product and somebody's interacting with your product through a website, there's a lot less that they're going to be able to tell you about, the structure of the software and what components are at play in the back end and the things that might have went wrong. Ideally, you are, working someplace that has some amount of documentation, right? And so you can go and find some architecture diagrams. You can find some written stuff or some videos that talk about, how things work and where things flow through the system. Obviously, at the end of the day, sometimes you just have to go to the code, and that's fine. You can't be afraid to do that. Um, it's almost always going to pay off to spend some time reading code and getting familiar with what's there. Um, reading code is reading code can be really difficult. I'm often reminded of a passage from a book. I believe it's The Chosen by Chaim Potok, which has nothing to do with software. It's about like a Hasidic Jewish kid and another different type of Jewish kid, and they become friends, but it's like forbidden friendship or whatever because they're different religions and blah blah blah. Anyway, the point is the one kid has like a um, a photographic memory, and he's trying to learn. I think he's trying to learn German or something because he wants to read. Uh, he wants to read Freud in like the original language, and he's like trying to read German and and um, he's like memorized all the vocabulary immediately, and now he just goes and tries to read it, and he's really really struggling. Then he has a breakthrough. He realizes he can't just read it like you would read a book. He has to study it. And then code is the same way. You can't just read it straight through, right? You kind of have to like look at the overall structure, start to like make notes about it, move on to different files, and then come back and then start to fill in the details. And um, you can't just read it through linearly. Well, first of all, it's very difficult to know where to start because it's not like it's organized like a book with pages, right? You open up a repo and there's like 50 files. And you're like,
Yeah,
where do I
that
read
makes a lot of sense, right? So, like, just because you understand the syntax and semantics of a language doesn't necessarily mean that you can speak it or especially understand it because of all the context needed to be able to have those ongoing conversations. Is that kind of what you're saying?
Yeah, and any sufficiently complex code base is kind of a new language on its own, right? Because code bases build up, functions and naming conventions and all these things that aren't part of the language the code is written in, that you start to have to wrap your head around to be able to easily understand the code. Um, and so I think if you understand that like anytime you dive into a new code base, it's not just do I know the language, it's I have to get familiar with like the local culture, right? Like that is essentially what it is. It's like going to the UK and trying to get French fries, or something like that.
That's a really good point. When you think about, you can use any, well, first of all, you can use any language to write bad, any programming language to write bad code, but you can use any language to implement many different architectures, right? Whether it's a monolithic architecture for value, or whether it's a microservices, or whether it's, like you said, SaaS or client server, right? Like there's a lot of different architectures, and just knowing the language doesn't give you enough information to be able to troubleshoot. You need that context, as you're saying.
That's right. Yeah, yeah. Language is important, but it's really only the first step. So a little bit of a tangent there. Let me try to get back to the agenda here. So strategies. Uh, Understand the system. Understand the problem. I think those are the first two things. Make sure you understand the problem, the context it's happening in. Gather information, and then make sure you understand the the actual system that you're working with, so that you can start to narrow down um, what the problem is. So let's say somebody's reported a problem, and now let's just jump to you can reproduce it, because we'll go down the you can't reproduce it path a little bit later. But let's say you've been able to reproduce the problem. Um, what do you do now? So this is pretty intuitive, I think, to a lot of people. You can just you can open a debugger, or you can just start to litter print statements throughout the code, to try to check it at various places to see if it is acting in the way that you expect it to or believe it should behave. Um, and I don't have a problem with either of those strategies. What I will say, though, is what's important to think about is how quickly can you reproduce the problem? Does it take 5 minutes to happen? Does it take half an hour? Or does it happen in like 5 seconds? Because debugging is almost always an iterative process. And that means you're going to be doing this over and over and over again. And however many times you think you're going to have to do it to figure it out, it's probably about 5 times that many. So if it takes 5 minutes, you could be looking at quite a long time with quite a lot of downtime. And that downtime, you might think, oh, I'll spend the downtime thinking things through and reading the code. But usually you just kind of get distracted. And so it's good to spend some amount of effort up front minimizing the reproduction, minimizing the reproduction of the problem. And this can take many different forms, but it has a ton of benefits. If you can really isolate that problem down to just one very small part, or something that can be reproduced very quickly, you're going to have a much easier time figuring out what's wrong.
Isn't there a term for
Um,
that? What's it called? Like minimal something to reproduce,
and
minimum problem statement.
reproduction, yeah.
One thing I want to touch on, if you could just, for the listeners, you provided two quick methods, and maybe you'll go deeper into both. One is kind of like logging, and the other is a debugger. So I remember, 20 years ago, when everything was private and expensive, and not everyone did software. Debuggers were fantastic because there's lots of money to be made. But then maybe about 10 years ago, at least from my standpoint, debuggers kind of went to the wayside because everything was free and no one invested the time in creating good debuggers. Can you share, like, is it expected of software developers today that yeah, you need to be an expert in a debugger, and yes, they're out there, and if you're not investing in being strong in a debugger and you rely on print statements, then you're doing yourself a disservice.
um, I have worked with very good engineers who I respect enormously, who are authors of prominent pieces of open source software, that are just like, yeah, I just do print statements. Um, and I've seen other people that absolutely love the debugger and are very efficient with it. Um, so it's certainly not a requirement to use it, but I think it is a good tool to be aware of. Um, I I don't use it very often today, and I probably should try to use it some more. It's been a long time. Back when I was like doing C stuff in school, I used a debugger a decent amount and got a lot of utility out of that. Because but like at the end of the day, you're usually doing approximately the same thing. You're looking at a place in the code and saying, I want to know what's going on here. And so at the debugger, you set a breakpoint there, you wait till it comes up, and then you can start stepping through line by line and inspecting the state of the variables and stuff. With a print statement, you just put a print statement there that prints out all the state you care about. And so if you can reproduce the problem really quickly, the print statement doesn't really lose you much time over using the debugger. If you can't, though, if it takes 5-10 minutes to get to that point, you might really want to use a debugger. There are some caveats, though, especially if you're doing like multi-threaded stuff. You can't, once you start enabling the debugger, or honestly, even adding print statements, you start to change, the interleaving of the various threads within your program, and you might see different behavior. So you do have to be careful of that in more complex software. But generally, I would say, experiment with both, do whatever you're comfortable with, and don't worry about it too much. Okay, so minimizing the reproduction of the bug is important because it improves your iteration speed, and it also narrows your focus. If I'm working on a bug right now where I know that we have data that goes through several different transformations before it gets to the end state, and if I can like basically stop it halfway, take the data as it is in that state, and write a test case that starts from there and does the back half, and it still exhibits the problem, well, then I've just eliminated half the code I need to look at, right? And so that's the kind of thing you can do. And when you do that, I would definitely recommend you use that sort of binary search methodology. And what I mean by that, because again, my co-host is not asking the obvious question.
What is binary search methodology? I mean, trees, man, like trees are a difficult concept for managers because it's got like, lots of different avenues.
Yeah, you look like you got a lot of trees in your life right now. So basically try to cut away half of the problem every step. So, if you're
that's divide and conquer. That's my favorite search algorithm.
It's
sorting
search
algorithm. Divide and conquer, man. That's not.
So you instead of like let's say I have a 10-stage pipeline. I'm not just going to remove the first stage. I'm going to remove the first 5. If the problem still occurs, then I know it's in the last 5. If the problem doesn't occur, then I know it's in the first 5. I've just cut out half the issue.
That's divide and conquer. That's divide and conquer.
Fine. It's also binary search. You can do the same thing with if you have a regression that is a bug that didn't used to exist and now does, you can do the same thing. And in fact, there's source control software has a command for it specifically. Well, Git does anyway. It's called git bisect, and it will automatically, if you give it like a known good commit and a known bad commit, and it will automatically pick one in the middle, run a test for you, and then based on whether or not the test passes, it'll do the binary search and get you down to the specific commit where the regression.
That's awesome. I was not aware of that. I mean, I'm more of an SVN CVS guy, right? But that actually is pretty darn slick.
Yeah, it's a nice thing, and you don't have to use git bisect to do it, right? You can do it manually if you're not using Git or don't have access to that or whatever. But that kind of approach, whether you're talking about removing pieces of your software stack to isolate the bug or searching through different commits to find a regression, it kind of works equally well. So minimizing, very helpful, very important. Definitely spend some time upfront, sort of minimizing the reproduction of the problem.
So one thing I think that is getting glossed over here because you're such an excellent engineer is that if you have not architected your system or program in such a way to allow for this, you're not going to be able to do a lot of the things you're talking about. You're not going to be able to kind of decouple and separate. So if you create these, what you call like a monolith or spaghetti code or all this stuff that just interacts in a, highly coupled way, it's going to make this all much more challenging, right?
That's a really good point. And if you find that your code is very difficult to debug, that's definitely a smell. That's something that you can use to direct you toward certain types of refactoring. To make that easier. Like if there's something that would be really useful to split apart, that's not easy to split apart. Well, you might consider a refactoring project to make that easier, because it'll probably pay dividends, right? If it
Yeah.
makes debugging easier, if it makes understanding your code base easier, those are all really good things.
And for the managers listening in, if you're trying to figure out a way to get that type of work prioritized, start looking at the turnaround time for your defects and how long they take to resolve, and go to the team and say, how can we how can we reduce this time, and measure it, right? Because then you're going to get a KPI that you can take to the business and say, look how much time we're spending on defect and not on feature improvements, i.e., opportunity cost lost to the company. So now you've just monetized your poorly designed software. And then if you talk about your refactoring and your goal is, let's say, 20-30%, you will now in turn see maybe like a 30% increase in velocity for defect management. Sorry for stealing thunder there, but for the managers listening in, that's how a way to approach that.
Yeah, no, that's great, because it is in like a business scenario, it is often hard to justify time spent on refactoring. Not tackling a bug specifically, but just refactoring to make things better in the future. And so any strategies you can employ to make that justification, or find the time to spend on that, um, it's important stuff to stay on top of. And isn't that, just not to take too much of a diversion, but like the big four software metrics. One of them is mean time to recovery, right?
Yeah, there's a paradigm for all of that. I tend to, I, my approach will be tend to put it on the team, right? You can't go to the business and say, oh, I need time to refactor. No, no, no. It's on the team to make their code supportable. And I think Google's rule of thumb is you should be spending 20% of your time refactoring your code, so continuous improvement. But yeah, from a metrics perspective, if your company's big enough and you've got enough teams, then yeah, those are the types of metrics you're going to want to measure and over time, because then it's like not just 6-man weeks, a 6-person team. It could be a 60-person team, and that's significant right there.
Yeah, I think what you choose to measure, will can help inform what you work on, and things like mean time to recovery, mean time between failures, uh, and I wish I could remember the other two off the top of my head. But anyway, let's go back to debugging. Maybe that can be a future episode. Um, all right, so we talked about reproduction, finding the minimal reproduction. Yeah, once you kind of minimize the reproduction, usually it's pretty easy to figure out the bug from there. Sometimes it's not. And So let's actually talk about um, the more difficult bugs. And I think the first category of that are bugs that you aren't able to reproduce. Like the customer is seeing it, and maybe they're only seeing it very transiently. Maybe they're only seeing it under very, very specific conditions that are difficult to reproduce. They've got 100 terabytes of data, and you just um, you don't have the resources to like spin up a thing and keep it up for long enough to reproduce the issue. What are strategies you can employ in this situation? And I'm sorry, I don't have any magic bullets here, but you do just have to be very pragmatic about how you approach this kind of thing, because it can be very difficult. Um,
Yeah,
the
this is
the first thing. Oh,
go ahead.
no, go ahead.
I was just going to say, and this is probably more of a management perspective, but I do think the most important thing is, is it really a problem? If it's a transient issue, if is it really hurting the customer? Is the response going from 2 seconds to 3 seconds, right? Like just, customer's always right. But if the customer's really angry about, a half a second or a second of a response time, is that really something you should focus on? Or, obviously if they're not able to do a critical function, that's completely different. But it is important in that first phase you were talking about with like, let's understand the problem.
Yeah, that's a really good point. And I should have had do not disturb on. Uh, you you don't always have to fix the bug, believe it or not. And it's definitely uh, it's definitely a good function that the manager can provide to dig in and say, like, how big of a problem is this? Do we need to prioritize this right now? Like, you don't have you also don't have to say no. You can say, like, it's just not at the top of the list, right? It's just a little bit down the list, and oh, sorry, things keep getting bumped ahead of it. Um, there's there's a lot of different things that can happen. Like, so you do have to think about, like, how much time is worth spending on this, because some of these bugs that are really transient are just um, they sometimes are just not worth the time, and it just doesn't make business sense to fix them here.
Yeah, so I think that what's important in those situations is, especially when talking with a customer, if I have a customer who's saying, "Oh, this bug is really bothering me," you talk about, okay, I can focus on this. It's going to take a good bit of time, but then you're not going to get these other features, and because software resources are limited. So I feel like you're not kind of forcing them to make the decision, but you're explaining to them the trade off of focusing on the bug. And honestly, my experience is more often than not they care more about the features because on their side it's really impacting service. But to your point, to exactly what you said, you can't tell them nothing. You can't say we don't have a plan for that. The plan may be, well, we're going to deliver these three features first, and then we're going to focus more energy on that. But I think you're spot on your approach there.
Yeah, and so that actually happens more often than you might think. So I'm glad you brought that up. If it does turn out to be something that really needs to be fixed, really needs some focus on it, there are a couple things you can do. One of them goes back to just understanding your code base really well and understanding the problem really well. So gather as much information as you can. And then, this is going to sound silly, but just go stare at the code and try to figure out how it's happening. You can find bugs that way, just by inspection, and sometimes you have to. And I've read about this happening at places like CockroachDB, where they have a big distributed system, and sometimes it's really hard to reproduce bugs. And they just have one of their engineers just dig in and look at the code and try to figure out what's going wrong just by inspection. It's not usually the first choice, but if you really need to squash that bug, it can be useful in these situations. The other thing that you can do is add more telemetry to the production system. So this is kind of like print line debugging, but in the production system. So just adding, figuring out, like trying to understand where the bug is happening and trying to get um, more context around it by adding extra telemetry to the production system. So this could be metrics, it could be logs, it could be there's all kinds of different paths you can take to do this. But this is a really nice way to show the customer that you're putting focus on this thing, show them that you're doing something, giving them a new build that has this telemetry, um, while not spinning your wheels trying to reproduce something that you just can't, either because of the scale or the complexity or whatever. So those are my, yeah. Go
Yeah,
ahead.
it's really interesting. So you talk about the telemetry. I have a different reaction to that. I don't know if I've been in software too long, but if I hear a software engineer say, if I've got a problem and they say, well, yeah, I added some more debugging, like that just feels like I'm being pushed off, right? That doesn't make me feel a sense of urgency that that software engineer or that team really feels my pain and is investing in it. So I get it, and I'm not saying it's not valuable, but it also requires you to push code to production, right? Which takes time and risk, especially if you're chasing an issue. So I'm not saying don't do it. I'm just saying from a customer management perspective, it feels a little lazy is a bad term, but it feels a little kind of like off point maybe.
Yeah, it's definitely like I said, it's not the first choice. Like all the other stuff we talked about, like try to find a repro, see if it's even like a problem that's worth solving. Um, try to look at inspect the code and see if you can find the problem. Like these all come first. If none of that's working and you've kind of had some back and forth with the customer, they're going to understand that this is a tough one. Usually, some customers are terrible. It's fine, it happens. Usually, they're going to understand like, hey, this is a tough one, and if you're involving them and saying like, hey, we're adding some extra metrics here and some logs here, um, and depending on how your system is set up, maybe you need them to send you the logs. Maybe you have immediate insight into it. But this shouldn't be the first thing you go to. You should be like, bug gets reported. Hey, we added some logs. Send those to us if you see them. But when it comes to this point, it can be really useful to avoid. Sometimes it can be the only feasible option, right? Like you just if you just can't reproduce it in your own systems, you might have to go down this path.
I really like how you explained that. So you work with the customer, you get them to feel that you do have a sense of urgency, and you talk about all the things that you have done and that haven't worked. And then that's when you go to this, I don't want to call it final step, but this more off hands off approach, which is okay, let's add some telemetry and let it soak for a little bit. And to your point, that probably really works in situations that are maybe transient and not super like mission critical.
Yeah, definitely. Okay, so that's so we talked about trying to reproduce issues, what to do when you can't reproduce an issue, um, different strategies for actually doing the debugging once you reproduce the issue. I think it may be time to look at. Oh, actually, there's a few more strategies I can talk about here. So we talked about reproduction, staring at the code. The other things you can do revolve around whatever observability tooling you have in place, and this actually kind of dovetails nicely with that last strategy, which is sometimes you can find weird correlations, like around when the bug is happening. So this is made easier if you have really good observability tooling. If you're using something like Datadog or Honeycomb and you have it set up really nicely such that you have all these like stacked graphs, and you can find like, oh, when this spikes, that's when the thing happens or whatever. But if you may not, be a SaaS service, you may not be paying a whole bunch of money for this type of tooling. You can still, bring up HTOP, or something in one terminal and strace in another terminal, and try to correlate like what system calls are happening with processor spikes or IO spikes or things like that. There's a lot of free, Linux tooling or whatever that allows you to observe different parts of your system, and that could be 7 other episodes, and there's probably whole podcasts on the topic of observability and performance tuning.
I'm a big fan of observability. I know it's frowned upon to say, correlation without causation, right? Like, oh yeah, that's just correlation. But what it's been my experience that, it may not be a cause, but the correlation component gets your mind thinking outside of your little box, and it gets you thinking about other things. And it may not be the problem, but it gets you thinking about different possibilities of the problem, which in my experience, like, is super duper helpful. And then even if you eliminate things that are not the problems, you've now just closed one more door of not the problem, which gets you closer to finding the door that is the problem.
Yeah, I mean, correlation doesn't imply causation, but it does kind of like, nudge and wink type of thing. Right? Like, maybe look here. Just check it out. Yeah. Yeah. You don't need to draw conclusions. You can just investigate. Anyway. Yeah. And so the other thing I will say is be cognizant of how much time you're spending on each strategy and thinking about whether it is worthwhile, or whether you should move on to something else. Don't don't go too far down this path of like over analyzing everything you're doing and deciding, getting decision paralysis about whether or not to do it. Because doing something is always better than doing nothing. But do every once in a while take a step back and think, hey, is this still worth it? Or should I pivot to something else? Because, sometimes the thing you're working on, even if you solved it, if you took 3 days to do it, it just wasn't worth it or whatever.
Yeah, little tip trick here for I don't want to talk about the P word, right, and start talking about process, but from an agile perspective, there's a cool trick called a time box, and the value of a time box is you can only spend X amount of time in a story. So if you're at any point you bring the team together and you say, here's the bug, how much time do we want to spend on it before we do something different? And it can be 1 day, 3 days, whatever it is. But to your point, Jaffee, that helps, that guardrail helps ensure you don't go down a foxhole and come up, 3 days later onto something that should have taken a half hour.
Yep, for sure. Okay, so we've talked about a few of these, but let's just go through some common pitfalls. Failing to understand the problem. Don't just chase down the first thing you hear, that came through the grapevine, from a customer to a frontline support person into a ticket, and then you read the ticket and say, all right, that's usually bad. Which goes to my second most common pitfall, which is not talking directly to the customer. And the customer doesn't necessarily mean the customer of your business, right? It's whoever's reporting the bug is the customer in this case. If at all possible, speak directly to that person in person, on a video call, on the phone, via chat, whatever it is. Try to get the most high bandwidth form of communication possible. Screen sharing is great. I have seen so many things on a screen share that help build context for me that I would not have known, just talking through it or just going on chat, because the customer doesn't always know what things are going to be salient to you. Like some customers will give you a ton of detail that's totally irrelevant. Some customers won't give you any detail. Just being able to take in exactly what they're doing, you will often see things that will jump out at you and say like, oh, like now this makes sense. Like, I'm kind of positioning it better. Being afraid to get on the phone with the customer is a huge pitfall, and it's a huge level up when you can do that and do it consistently and aren't afraid to sort of come out of your shell and actually interact with the user. Third thing, I think we basically covered it, but jumping to conclusions. There's a great quote, and I don't know why this popped into my head. Again, from a book that has nothing to do with software, but it's talking about people, and it's saying people will believe a lie because they want to believe it's true, or because they're afraid it might be true. And when I say people here, I'm talking about you, the software developer. If somebody reports a bug to you, and maybe it's in some code you were in recently, if there's something you're worried about in that code, maybe it has some like really gnarly, potential like multi-threaded race conditions or deadlocks or something, your mind is going to jump right to that. Or if you were just thinking about all right, maybe you just read an article about how sometimes in Go the scheduler can really bog down and make things really slow. Your mind will immediately jump to that because you're afraid that might be the case. And you're like, oh man, it's going to be really hard to like figure that one out. Don't do that. Understand the problem and work the process, because I've seen it happen so many times where somebody jumps to like the most dire possible conclusion, starts going down that path, and you can waste a ton of time when it turns out to be an off by one error, or something really silly. It's you remember the ones that are really hard, but it's usually something really silly. 95+% of the time, you're going to knock out this bug and forget about it. And the 5% of the time that's something really terrible and you spend multiple days on it, those are the ones you remember. So it feels like every bug is that way, but it's really not.
Yeah, I want to add a sub bullet to that if I can. Just a little bit management perspective. I would encourage every engineer, if your boss or somebody at the company asks you, well, why is that a problem? the answer shouldn't be because the customer is upset, right? Like that's not a product answer. A bug is at what Jaffee introed with. It's undesirable behavior in the system. You need to understand that. You need to be able to um, explain that in terms, like in business value terms, of why this is a problem, not because I was told to do it or because the customer's upset, right? Like why? Like the system's not supposed to behave this way because of A, B, C, X, Y, Z. It's critical you understand that context, or you're not going to be able to understand everything that kind of Jaffee's going through.
Absolutely. And before I forget, that quote is Terry Goodkind. I had to look this up because I like dredged it up from my memory, but I probably read this book like 20 some years ago. Terry Goodkind, I believe it's from the Sword of Truth series, which is just a swords and sorcery fantasy novel series. But I think that's like, I just think it's very true in life in general. Like people will believe things that they want to believe or that they're afraid are true. So don't get caught in that trap when you're debugging. Uh, the next pitfall, I just wrote one word for this one: despair. Don't look at a bug and just throw up your hands and despair, because of all the things we've talked about today. Because we have strategies. Because we have, hey, like we're just not going to spend infinite time on this if we don't, like it may just not be worth it. Like there's never any reason to just give up, and not even try, because at the end of the day, you need to do what makes sense for the business, and um, there's always many paths that you can go down to either try to figure it out or try to work around it or make it not a problem. So try not to fall into that trap of thinking like, oh, this is just too hard. Like I'm never going to be able to get this. It's going to take forever. It's not useful, um, and there's always something you can do. Which brings me to my next point, which is not getting help and not talking through the problem. Have you've heard of the rubber duck thing?
Rubber ducky, you're the one. They
Yeah,
make bath time lots of that thing.
yeah, exactly. So you have a rubber duck on your desk, and you explain the problem to the rubber duck, and in doing so, you help yourself understand the problem better, and you have insights. And this works a ludicrous percentage of the time, but it's even better if you explain it to a real person and are kind of forced to like walk them through it. Either they'll see something, or more likely, honestly, you'll see something that you missed initially, and that'll help you get to the bottom of the issue. Which brings me to my last point.
So, but before you get to your last point, I want to add, like, it's real world what you're talking about. That the last two issues of despair and regurgitating it to other people are super important. As a manager, as a product owner, as a scrum master, there's two user story states that are my favorite, and they are rejected, won't do, blah blah blah, or rejected, working as designed, right? Like, and those are completely valid states for user stories. There's sometimes, and when a customer comes in, or internal external stakeholder, and says the system should be operating this way, you may not be a big enough company to invest weeks of time on this thing that one customer is having every other week, right? So rejected won't do because the opportunity cost to this is just too high, or the customer doesn't understand the system right. And yes, they want it to work a certain way, but it doesn't, and we're not going to change it for that customer. So we're rejected worked as designed. So don't despair if that ends up being your bug's resolution state.
Yeah, definitely. So the last thing is disorganization, and what I mean by this, and why it's related to the previous point of not getting help, not talking through the problem, is, remember we talked about debugging being an iterative process. Sometimes you're trying lots of different things and seeing how the system behaves. It's very easy, especially if you have sort of a complex reproduction where you've got like this thing running over here and it's this version, and then you've got your test script over here and you've just made some tweaks to it, and you're running the test script, but then you made a change to the software. You got to recompile the software and rerun it. Like forgetting to recompile after you made the change, forgetting to save your test script, forgetting to set up the environment properly. when you're doing stuff over and over and over, and you're trying to go as fast as you can, and maybe you have multiple experiments running at once, God forbid, it's so easy to make a mistake and then get really confused about what's going on. You're like, no, that how can it be behaving like that? Like I just changed that thing, and I thought that was going to fix it, and you just get into these really weird states. You have to be organized. You have to write down what you're doing, and honestly, just automate as much as possible. Like you can say make install and run the thing in a single command. So you just rerun that command, and every time it's going to recompile it and run it.
Is
You
this
don't have to remember to compile and then run.
is this the astrophysicist lecturing on the scientific method? Because I'm just like I'm just gonna put me to sleep.
I'm sorry. I don't. It's not even scientific method. It's just like don't get bogged down by your own silly mistakes. Right? Like you're going to get tired, and it helps to have someone looking over your shoulder some of the time. It helps to write things down, and it helps to automate things. But just know that if you have a complex process for reproduction, you're probably going to screw it up at some point, and then you're going to start questioning your own sanity, and that's not a fun place to be.
Do you find that pairing on complex issues is a good practice or not a great practice?
I love pairing. Not like 100% of the time, uh, but it can be really really helpful. When you're trying to understand something, or you're trying to design something new, and anytime you have to make a lot of like micro decisions, I think pairings are really helpful. Just to have someone who's like looking over your shoulder and saying, yeah, that makes sense. Yeah, that makes sense. Yeah, that makes sense. Because otherwise, you just kind of get decision fatigue, and you're like, I don't know if I should do it this way or that way, and that's no fun. And then when you're debugging, just having someone who's helping you say oh no, you forgot to do this, you forgot to recompile, whatever it is. I think that's really beneficial. And then of course the upshot of that is once it's done, you have two people that understand the thing instead of just one, which is a really nice property when you're working on development teams.
Yeah, I think to your point about writing things down and making sure that you're being descriptive about it. There may come a time where you're not able to solve it and you have to hand it off to somebody else, and you don't want to hand off gobbledygook. You want to be proud of the work that you did, even though you didn't maybe accomplish it.
That's also true. I've definitely been in states where someone's like, well, can you hand off this work? And I'm like, I've got like changes scattered throughout 3 repos, and like a bunch of like hacky half scripts. And I'm like, you don't really want to hand this off. It's going to take.
Yeah, I don't want to make this about management, but one of the hardest management times is when one of your top engineers says, "I just need 2 more days." And I just need 2 more days, and then they do that 3 or 4 times, right? Like, it doesn't matter who your engineer is.
I hate it when they do that.
You have a obligation to the business to I don't want to say not care about feelings. That's not the point. But what matters is that the problem gets solved in the expedited amount of time. So, as an engineer, you're going to be in service to your company by making sure you document it, because you may not get those 2 extra days.
Yep. Okay, so I think we're about ready to wrap this up. I just want to hammer home the point. Make sure you understand the problem. Make sure it's actually a problem that you want to go spend time on as a business. Try to reproduce it. Try to minimize the reproduction. Know what you can do if you can't reproduce it, and don't be afraid to ask for help. Stay organized, and walk through the problem with others, and don't despair. I think that's it. Any final thoughts, Jason?
Yeah, I want to make sure all the engineers listening, and for managers who kind of want to think about, everyone sees that results. I'm results oriented, right? I can tell you as a manager, I do not care who solves the problem. I don't care if it's assigned to you and you get help and you get it solved. I truly do not care. I care that it is solved. Now, if everybody's doing your work, that's a different conversation. But don't ever be afraid. Don't I like the word despair. Don't ego check at the door, right? Like, get the task done. Put guardrails in place, right? Write it down. Everything that Jaffee went over, write it down. If you come up in 2 days and you say, you know what, boss, I'm not the right person to fix this issue. I've documented it. I can't find it. The right thing to do is hand it off. I can tell you that's what your boss wants to hear. He doesn't want to hear in 8 days from now that you didn't solve it and you just need 2 more days. So completely agree, and don't be afraid to ask for help.
Yeah. All right. Well, I think that's a good place to wrap us up. Hopefully this generates some good discussion. And if you have any questions or anything else you want to hear about, you can always hit us up at SmartSnarkcast on Twitter, smartandsnark@gmail.com. And I think that'll do it. Have a good one.
Rubber ducky, you're the one. You make bath time lots of fun.